Okay, so here we have question 9, moment of inertia of a composite body, or section 9.2. So here we have a 2D TV remote. Now because it's a 2D TV remote, we actually don't have to worry about these buttons, so we can get rid of them. Now, the question is asking for us to determine the moments of inertia for x and y direction um, along the centroidal axis, or the centroid. So when I go to do this, I pretty much get to ignore the buttons and then look at just two main shapes. So in order to work on this, my first thing I have to do is create a chart, because I have to figure out what my centroid's going to be. So for this, we're going to have our shape done. We're going to have our shapes, which are already numbered for us. We're going to calculate the area of these shapes in centimeters squared. We're going to be calculating out our x bar, and we're also going to be calculating out our y bar. And along with that, we're then going to be multiplying our x bar and our y bars by the area. So that means that we have a x bar and a y bar. So going into this, that's what we will be focusing on and trying to calculate out. And then with that, we're going to do it for each of these shapes, and then we're going to add them together. So we have shape 1, we have shape 2, and then we're going to have sigma just for adding it together. Now for sigma, we're not going to be getting sigma for our x bar or our y bar, because it's actually not helpful there. Because when we calculate out our centroid, what we're looking for is sigma of a times x bar or y bar. It could also be y bar, and when we calculate out y bar, all divided by sigma of a. So, but let's worry about that later and get started now. So as we do this, for shape 1, we're going to start off by calculating out our area. As you could tell from our diagrams on the side, the area of an ellipsoid is pi times alpha times beta. So alpha for us is going to be this 0.5 centimeters, and beta for us is going to be the 2 centimeters that is over here, but we're going to divide it by 2 because we need to get the radius of that. So 2 divided by 2 equals 1 centimeter for radius. So when I calculate this out, I'm going to do pi times 0.5 times 1. And then I'm going to take that number and I'm going to divide it by 2. And when I do that out, I'm going to get, so pi times 0.5 times 1 equals about 1.57. Now I'm going to have to divide that by 2 because I only need the area of a semicircle. So when I do that out, I'm going to get 0.785. Now I'm going to be calculating the area of my rectangle. Now the area of my rectangle is just base times height, or 2 times 10, which equals 20. So now we're going to be looking at calculating out x bar. Now x bar is pretty simple. It actually uses a formula of x bar equals, because this is for an ellipsoid, keep in mind, x bar equals 4 times a, all divided by 3 pi. So when I plug in that in up here, I'll have 4 times 0.5 all divided by 3 pi. Which when you do out, you're going to end up getting about 0.212. So now we're going to move on and start calculating out our x bar for our rectangle. Now that one's a little easier because all I have to do is I have to take my 10 and I have to divide that by 2. So 10 divided by 2 equals 5. So, however, that would be if it was pressed against the y-axis. However, it's not. Right now, we actually have this gap of 0.5 centimeters that we already right here before the rectangle actually starts. So we actually have to add 0.5 to that, which then gives us 5.5. Now we're going to be calculating out y bar. Now, because the semicircle actually still has the full upper part and lower part on the left side, the y bar of an ellipsoid, well, that's like that, is just going to be the center. And the center here occurs at 2 divided by 2, which is 1. And now we're going to do the exact same thing for the rectangle. We're going to take that 2 and we're going to divide it by 2 because there it's going to occur at 1/2 of the height. So that ends up giving us 1 as well. So now we're going to be working at our a times our x values. So if I take my 7.785 and I multiply that by my 0.212, I'm actually going to get my area in the x direction to be 0.16642. Now I'm going to do the same thing for my rectangle. I'm going to take that 20 and I'm going to multiply that by 5.5. And when you do 20 times 5.5, you're going to get 110. So now we're going to start working on our our a times y bar. So when we do that, we're going to take our 0.785 and we're going to multiply that by 1. And when you do that, you're going to end up getting your 0.785 back. Now we're going to do the same thing for our rectangle. We're going to take our 20 and we're going to multiply that by 1, which gives us our 20 back. So that being done, we now move on to calculating out our totals. So I'm going to start off with the area again. So when I add 0.785 to 20, I'm going to get 20.785. I'm now going to do the same for AX. When I do that, I'm going to get 110.16642. Now I'm going to do the same for A times Y bar. And when I do A times Y bar, I'm going to end up A plus Y bar, my bad, and get my totals for there. It's going to be 20.785. So now I'm going to be using this formula here that I already wrote down to solve out and try to get my answers. So first things first, when I'm doing this, I'm just going to start off with my x bar. So my x bar here is going to equal this 110.16642 divided by 20.785. And when I do that out, I'm going to end up getting When I do that out, I'm going to end up getting 5.30. So now I'm going to move on and start working and do the same thing for my y bar. My y bar is going to be, going to take my total of 20.785, and I'm going to divide that by my total of my area, which is also 20.785, which means my centroid in the y-axis is 1, which makes sense because both of the centroids for my shapes were at 1 as well. So now that we have our centroids, we're going to actually start working on getting our inertia and our moments of inertia in respect to the centroid. So in doing that, we're gonna create a chart that's very similar. We're gonna still do our shape. We're gonna do our shape. We're gonna do our area again. Except instead of writing x bar and y bar and then ax and yx, we're actually gonna start calculating out our inertias. So based around the actual origin of the shape and the x direction, we're then going to also get the distance our value is from where the centroid is. And then we're then going to calculate out our a dx squared. Now we're going to do something similar for y. We're going to do I times I sub 0y. We're then going to grab dy, and then we're going to grab a of dy squared. Now we're just going to split this up. We're going to use 3 columns again. Three rows. First 2 are for the shapes. The last 2 are for, the last 1, is for sigma and just totaling everything up. So shape 1, 2, and sigma, just to get totals. Now, when we're doing sigma here, we're actually not going to be calculating out sigma of dx or dy. Those ultimately will not actually have an effect for us, so we can kind of just push those aside and ignore them. However, we're still going to need our areas. So 0.785, which we calculated on our last table, 20, and 20.785. Now we're not going to use our total area on this, but it's still helpful to write down and just remember. So now we're going to start calculating out our inertia values. So our inertia we can actually get from these right here. Now, for the rectangle, we actually don't need to change that formula at all. But when we're looking at our ellipsoid, if you notice, this is actually for a full ellipsoid. However, we need to make that for a semicircle, well, a semi-ellipsoid. And when I do that, I'm going to have to take these values here, and I'm going to have to divide them by 2. So when I divide those by 2, I'm going to get I sub x equals pi over 8 ab cubed, and I sub y equals pi over 8 a cubed b. So now we can actually start working on getting our inertias. So first things first, with our inertia, we're going to calculate out our pi divided by 8 times our alpha times our beta cubed. Now we already know that our beta is going to be 1. So we can actually erase this and rewrite that as 1, and 1 cubed is still going to be 1. Our alpha, though, is going to be 0.5. So when I multiply all this out, I'm going to get a value of about 0.196. So now we're going to move on, though. And we're going to do the same thing, but this time for a rectangle. And a rectangle uses this formula up here, the 1 divided by 12 times bh cubed. So we know our base is 10. So we're going to do 1/12 times 10 times our height cubed, which is 2, times 2 cubed. And when you do that out in your calculator, you'll end up getting about 6.667. Now we're going to add these values together for sigma for us. And when we add them together, we're actually going to get 6.863. Now, that does not mean our inertia that is our final inertia, because that's not fully yet around the centroid of the problem. So first we're going to look at dx. And the way that we get dx is we actually look at our y bar and see how different the y bar of our shape is from our overall y bar. So when we look at this, it's actually our overall y bar for the entire TV remote is 1, while both of our shapes also have 1. So that means we'd be doing 1 minus 1, which gives us 0 for both of them. Now, given that we know that dx equals 0, we can then take our a dx and we for both of those, and those are both going to be 0, because if you square 0 or multiply anything by 0, you're going to get 0. This means our inertia in the x direction Our inertia in the x direction about the centroidal axis equals our 6.863. Because we're going to be taking that value and adding 0 to it, and when you do that, you're going to get that. So now we're going to start worrying about our y direction. Now we're going to be doing something pretty similar to what we just did for the x, but this time it's going to be just using the y direction. So when I calculate I out for that, I'm going to be doing still the pi divided by 8 times alpha cubed times beta. Now we know beta to be 1. We know alpha to be 0.5 cubed. So now when we do this out, this is going to equal about 0.049. Now we're going to do the same thing for our rectangle. If you remember, our rectangle was 1 over 12 times our base cubed now, so 10 cubed times 2. When I multiply all of that out, I'm going to get about 166.67. So now I'm going to get a total for these. When I I'm going to get a total. Sorry, that should be 0.667. So now I'm going to get my total for my I there, and in which case I'm going to get about 166.716. Now we're going to be looking at getting our dy values. So for our dy values, we're going to actually be taking our x bar value of 5.3, and we're going to be figuring out how different that is from the x bar values of our other problems. So the first one we're going to be doing is we're going to be doing it with the rectangle. And now the x bar for the rectangle was 5.5 if you remember. So I'm going to subtract 5.3 from that, which gives us 0.2. And that would be our dy. Now I'm going to do the same thing for my for my ellipsoid. So I'm going to be taking that, except this time, because it's always going to be positive, my dx or dy will always be positive, so it doesn't matter which way I subtract them. So this time though, because I know 5.3 is larger, I'm going to do 5.3 minus our value of 0.212, which when I do out, I'm going to end up getting about, I'm going to write it up here just that way it's easier to see, 4.903. So wait, hold on. Sorry, my bad. I have to actually, hold on. Let me actually do that out again. 5.3 minus my 0.212, which will get me about 5.088. So now I'm going to actually look at calculating out my ADY value. So I'm going to be taking my area of 0.785, because we're going to be starting with our ellipsoid, and I'm going to be multiplying it by that 5.088 value that I got squared. When I do that out, I'm going to end up getting, about 20.322. Now I'm going to move on and do that for my rectangle. So I'm going to be taking my value of 20 for my area, and I'm going to be multiplying that by my 0.2 squared value that I got for dy. And when I do that out, I'm going to end up getting, end up getting about 0.8. So now I'm going to add these values together. And when I add these values together, I'm going to get about 21.122. So now in order to calculate, now this is a little more complicated when I am getting my final inertia around the centroidal axis because I have these value here and I have the value here. But it's not much more complicated. All I simply do to get my I sub y value is I take this equals my I sub 0 comma y, and I add my a dy squared. And now keep in mind, this would be my sigma. This would be sigma for both of these, not just for one point. It's sigma for both. So when I do this, I'm going to be doing that 166.716, and I'm going to be adding my 21.122. And when I add this together, I'm going to end up getting I'm going to end up getting 177.838. So I'm going to rewrite this so it looks nicer, but ultimately my moments of inertia, x and y, about the centroidal axis happens to be, in the x direction, it is 6.863, and in my y direction, it happens to be 187.838. Now, if you look at this, we can look at these values, and we can actually say that our y value will be our strong one then. But that is our final answer. Thank you.